Welcome to our case study on aviation human factors. We'll explore the Boeing 737 MAX and maneuvering characteristics, augmentation system incidents from 2018 to 2019, focusing on multi-level failures and safety constraints that failed across the system. The Boeing 737 MAX faced critical issues: larger engines, altered handling, leading to maneuvering characteristics, augmentation system software compensating with nose-down trim. This system relied on a single sensor without redundancy. Tragically, this led to the loss of Lion Air 610 and Ethiopian 302, with 346 lives lost due to the same failure pattern. Safety-critical systems require constraints to ensure safety. Maneuvering characteristics. Augmentation system had significant control over the aircraft, but lacked these constraints. The issue isn't about individual errors, it's about identifying which system level failed to enforce necessary safety measures. The Federal Aviation Administration failed to impose necessary constraints, not requiring redundancy for safety-critical systems. No backup or explicit crew training was mandated. Certification responsibilities were delegated through the Organization Designation Authorization Program, placing safety assessments in the hands of the manufacturer's engineers. The manufacturer classified maneuvering characteristics augmentation system as a minor change, bypassing necessary human factors evaluation. Cultural resistance and pressure to avoid re-examining completed certification work kept critical gaps hidden. Airlines were not provided with the necessary information to develop an abnormal procedure for maneuvering characteristics augmentation system. Consequently, crews lacked a mental model, as the behavior resembled various other failures, none of which matched their training. System-theoretic accident model and processes identifies missing constraints, not isolated faults, as the issue. Each level, regulator, manufacturer, operator, failed to enforce constraints that could have prevented maneuvering characteristics augmentation system issues. A pre-certification analysis would have revealed the single sensor dependency early on. The 737 MAX constraint failure teaches three key lessons. Safety relies on identifying missing constraints and enforcing them. Delegation of certification requires oversight to maintain independent checks. Prospective constraint analysis is crucial for identifying gaps before accidents occur rather than explaining them afterward. The 737 MAX case is analyzed as a constraint failure in Chapter 2 of Aviation Human Factors, Theory, Research, and Applications for Advanced Aviation Systems by Ziakas and Peklavanis. This chapter explores various theoretical frameworks and system models layered on this event.